What if everything we thought we knew about ancient civilizations was only half the story? Picture this: massive stone structures rising from the desert, intricate carvings whispering secrets of forgotten sciences, legends of gods who commanded the rain and wind. Now imagine that these weren't just myths or metaphors, but real, tangible technologies. What if ancient peoples didn't just survive their environments, but actively shaped them? What if they could calm a hurricane, summon rain in a drought, or redirect the wind itself using systems so advanced we're only just beginning to understand them? This is the mystery of the storm vaults, a concept that blurs the line between legend and historical possibility, between spiritual belief and sophisticated environmental engineering. Today, we're setting out on a journey to explore one of history's most captivating enigmas. We'll travel across time and continents, from the wind-swept plateaus of Peru to the submerged ruins whispered to be Atlantis, from the coded texts of the Vedas to the silent, staring majesty of the Sphinx. Along the way, we'll examine astonishing architectural feats, decode mythological hints hiding in plain sight, and consider strange geological anomalies that science still struggles to explain. This isn't just an exploration of the past, it's a re-examination of human potential. It challenges the narrative that ancient people were primitive victims of nature, and instead paints a picture of innovators who worked in harmony with the world around them, using tools and wisdom that somehow slipped through the cracks of time. More than that, this investigation meets us right where we are today, in an era of climate uncertainty, where rising temperatures, extreme weather, and ecological fragility dominate global conversations. What if the solutions we're searching for have roots that reach back thousands of years? What if ancient environmental mastery holds clues that could help us rebalance our relationship with the planet? This video is an invitation to wonder, to reconsider, and to rediscover a forgotten chapter of human ingenuity. So come with us as we unravel the storm vaults, decode the secrets of climate control buried in antiquity, and reimagine what's possible when we listen closely to the echoes of the past. The term storm vaults itself sounds like something from a fantasy novel, but it's a concept that emerges from a fascinating intersection of archaeology, mythology, and cutting-edge climate science. So what exactly are we referring to when we use this phrase? At its core, the idea of a storm vault suggests a deliberate, sophisticated system, an installation or a network of technologies designed not just to withstand nature's fury, but to actively manage it. We're talking about the possibility of ancient structures or natural formations engineered to capture, store, and redistribute atmospheric energy. Imagine vast subterranean chambers that could collect and condense moisture from the air to create reservoirs during a drought, or towering, precisely aligned stone arrays that could deflect and calm hurricane-force winds. This isn't about magic, it's about a potential lost science of geoengineering and environmental harmony that ancient cultures might have mastered. To understand where this idea comes from, we have to dive into the world's oldest stories. Across countless cultures, myths are filled with accounts of weather manipulation. In Mesopotamia, the Epic of Gilgamesh describes the god Adad who wielded the winds and storms. In the Americas, the Maya Popol Vuh speaks of deities who summoned rain and shaped the world with hurricanes. For a long time, historians interpreted these tales as purely symbolic, a way for early humans to make sense of the terrifying and unpredictable forces of nature. But what if these stories were more than just allegory? What if they were actually preserving technical knowledge? The Hindu Vedas, for instance, describe intricate rituals and precise structures called yantras that were said to control atmospheric conditions. These texts read less like prayers and more like instructional manuals, detailing specific materials, orientations, and even sonic frequencies needed to influence the weather. This shift in perspective is crucial. It suggests that the line between a shaman's rain dance and an engineer's climate control system might be far blurrier than we ever assumed. This theoretical framework starts to feel much more tangible when we look at physical sites around the globe. Take, for example, the ancient wind catchers of Persia, known as badgers. These remarkable architectural features, some dating back over 2,000 years, are towers designed to catch even the slightest breeze and funnel it down into the living spaces or underground storage rooms below, providing natural air conditioning and preserving food in the desert heat. Could this principle have been scaled up? Could a network of such towers have been used to redirect larger air currents or influence local precipitation patterns? Then there are the vast underground cities of Cappadocia in Turkey, like Derinkuyu, which plunge deep beneath the earth. While their primary purpose is thought to be protection from invaders, their sophisticated ventilation shafts and constant, stable internal temperature point to a profound understanding of subterranean climate dynamics. These are not just random caves, they are engineered environments. When we place these archaeological wonders alongside the mythological texts, a compelling pattern begins to form, one that points to a widespread, ancient understanding of how to work with the Earth's natural systems. Modern researchers are now exploring a range of fascinating theories about how these storm vaults could have actually operated. Some speculate they were geological in nature, utilizing specific mineral compositions or crystal formations known to possess piezoelectric properties, meaning they generate an electrical charge under mechanical stress, potentially influencing atmospheric ions and cloud formation. Others propose they were acoustic devices. Ancient monuments like the Hypogeum of Hal Saflieni in Malta feature chambers with incredible resonance properties, where a specific frequency can be felt throughout the entire body. Could sustained sound waves have been used to agitate the atmosphere, encouraging cloud condensation or even dispersing fog? There's also the intriguing possibility that these systems were a combination of all these elements: architectural, geological, and acoustic working in concert. This holistic approach to technology, where science and spirituality were not separate but deeply intertwined, might have been the key to their success. By starting with this foundational definition, we begin to see the storm vaults not as mere legend, but as a plausible, though lost, chapter in human history, setting the stage for a deeper investigation into their incredible mechanisms. Now, let's turn our attention to the very stones left behind, the silent giants standing sentinel across millennia. The first and perhaps most compelling clue in our investigation lies in the architectural marvels that defy simple explanation. These aren't just piles of rock, they are intricate puzzles, and when we look at them through the lens of climate control, a startling new picture begins to emerge. Take the Great Pyramid of Giza, for instance. Its precise alignment to the cardinal points is often discussed in spiritual or astronomical terms, but consider the practical effect. This orientation isn't just for show. It interacts directly with the prevailing winds of the region, potentially channeling airflow in a way that could reduce sand accumulation or even create specific pressure differentials across the Giza Plateau. It's a feature that serves a purpose far beyond the symbolic. Then there's the legendary Hanging Gardens of Babylon, one of the 7 wonders of the ancient world. While its exact location remains debated, ancient descriptions paint a picture of an astonishing feat of hydroengineering. Imagine a massive, ascending series of gardens, not just relying on rain but fed by complex irrigation systems that lifted water from the Euphrates River to the very top. This wasn't merely a beautiful royal garden, it was a deliberate creation of a microclimate. The constant evaporation from the lush vegetation and flowing water would have significantly cooled the immediate surrounding air, a welcome relief in the scorching Mesopotamian heat. This suggests a sophisticated understanding of how water and plant life could be used to actively modify and tame a local environment, turning a section of the desert into a cool, humid oasis. This principle of intelligent urban planning for climate resilience is spectacularly evident in the cities of the Indus Valley civilization, such as Mohenjo-Daro and Harappa. These were not chaotic collections of buildings but meticulously designed metropolises. Their most striking feature, a highly advanced city-wide drainage and water management system that was centuries ahead of its time. Every house had its own bathing area and was connected to a network of covered drains that ran beneath the streets, directing wastewater away from living spaces. But this goes beyond simple sanitation. Such an extensive system for controlling water flow hints at a profound knowledge of hydrology that could easily have been applied to larger atmospheric challenges. The Great Bath at Mohenjo-Daro, a large, waterproofed public tank, might have served roles beyond ritual cleansing, perhaps as a central reservoir for regulating groundwater levels or even influencing local humidity through evaporation. The materials chosen for these ancient constructions also tell a fascinating story. It wasn't just about using the nearest or strongest stone. There appears to have been a deliberate selection based on the properties of the rock itself. In many cultures, limestone was a favored building material. Beyond its workability, limestone is highly porous and hygroscopic, meaning it naturally absorbs and releases moisture from the air. In a humid climate, this could help reduce dampness, while in a dry climate, it might slowly release stored moisture, subtly moderating the aridity. Even more intriguing is the use of quartz-rich stones in certain monuments. Quartz is piezoelectric. It generates a small electrical charge when subjected to mechanical pressure, like the constant vibration of the earth or even sound waves. Could vast structures embedded with quartz have been designed to interact with the atmosphere's electrical charge, potentially influencing cloud formation or storm patterns? The choice of materials moves from mere construction to potential function. When we step back and view these structures not as isolated tombs, temples, or palaces, but as interconnected components of a larger environmental system, the conventional narrative of ancient people begins to crumble. They were not passive victims of their climate, simply hoping for rain or praying for the winds to calm. The evidence etched in stone suggests a society of active participants, of ingenious engineers who sculpted their landscape with a deep understanding of natural forces. They positioned their cities to harness natural wind tunnels. They built vast networks to manage water with precision, and they selected stones that actively interacted with the atmosphere. These architectural anomalies are the first solid footing in our quest, the physical proof that forces us to ask not if they could control their climate, but how. Moving beyond the silent testimony of stone and architecture, we find our next compelling clue woven into the very fabric of ancient stories. Myths and legends from every corner of the globe are saturated with accounts of weather manipulation. But what if these were more than just imaginative tales told around fires? What if they were a sophisticated method of knowledge preservation, a way to encode complex engineering principles within memorable narratives for future generations? This idea transforms our understanding of these stories from mere folklore into potential historical records, blurring the line between the divine and the technological in a truly fascinating way. Consider the immense detail found in ancient Hindu texts like the Vedas and the Mahabharata. They don't just vaguely mention flying machines called vimanas. they provide startlingly specific descriptions. Some passages detail their construction from specific metals, their power sources which sound eerily like mercury vortex engines, and their capabilities, which include precisely influencing weather patterns, creating protective barriers of mist, summoning rains, or even generating devastating winds as weapons. This isn't the language of pure fantasy. It reads more like technical documentation, carefully wrapped in a mythological context to ensure its survival across centuries. Similarly, in Greek mythology, the god Zeus doesn't just haphazardly throw lightning bolts. He wields them with a specific tool, the finely crafted aegis, a shield that could create storm clouds and terrify enemies. This could be interpreted as a mythological representation of a focused energy device, its operation and effects encoded in a story about a god's weapon. This pattern of embedding practical knowledge within spiritual metaphor is perhaps most beautifully illustrated by the Aboriginal Australian concept of songlines. These are not merely songs but intricate oral maps of the land, detailing water sources, topography, and navigation routes. The belief is that by singing these songs in the correct sequence and with the right tonal frequencies, the ancestors literally sang the world into existence during the dream time. From a modern perspective, this profound connection between specific sound frequencies and the shaping of the physical environment resonates deeply with cutting-edge scientific research into cymatics and acoustic levitation. The stories ensured that this sacred, place-specific knowledge was passed down accurately, preserving a holistic understanding of how to interact with and care for the land, which could easily include methods for encouraging rainfall or preventing erosion through vibrational practice. Esteemed scholars like Dr. Jane McIntosh support this view, arguing that in predominantly oral cultures, myth and ritual functioned as the primary textbooks. Complex information about agriculture, astronomy, and yes, even environmental engineering had to be memorized. Wrapping this data in engaging stories with memorable characters, dramatic conflicts, and rhythmic poetry made it far more likely to be accurately transmitted across generations without being lost or corrupted. A ritualistic rain dance, therefore, might not have been a simple plea to the gods but a carefully timed community activity based on observed climatic cycles, potentially involving the burning of specific chemicals to encourage cloud seeding or the use of rhythmic drumming at a frequency known to influence atmospheric pressure. The ritual was the delivery system for the science. This theory moves from the abstract to the astonishingly concrete when we cross-reference these myths with tangible archaeological discoveries. In the high Andes of Peru, researchers have uncovered strange, finely carved stone tubes and hollow artifacts near ancient Nazca sites. When blown into, these objects produce powerful, low-frequency sounds that are felt as much as they are heard. Local legends speak of priests using such instruments to call down the rain from the mountain peaks. Suddenly, the myth provides a compelling context for the artifact. It suggests a practical application, that these were not ritual noisemakers but potentially refined tools, used in an understood, though now lost scientific process to interact with the atmosphere. The story preserved the purpose of the technology long after its method of operation was forgotten. This profound interplay between myth and physical evidence suggests that the storm vaults were far more than just cleverly designed buildings or geological formations. They were also cultural and intellectual vaults. The knowledge of how to operate and maintain these systems was embedded within the songs, stories, and religious practices of the people. The myth was the user manual, the ritual was the activation sequence. This holistic worldview, where science, spirituality, and community were completely intertwined, may have been the true secret to their success, ensuring that the wisdom of environmental stewardship was woven into the very identity of the culture. As we learn to decipher these ancient texts and traditions not as superstition but as coded wisdom, we gain invaluable insights into a forgotten philosophy of balance, a way of living with the earth that we are only now, in our age of ecological crisis, beginning to desperately relearn. Now we venture beyond the structures and stories to the very land itself, where some of the most persuasive evidence for ancient climate engineering is written not in stone or scrolls, but in the soil and the climate records of the planet. Across the globe, there are pockets of environmental oddity, places where the climate or geography behaves in ways that don't quite align with our models of natural development. These anomalies present a tantalizing third clue, suggesting the fingerprints of a sophisticated, guiding hand in the distant past. Consider the Sahara Desert. Today, it is a vast ocean of sand, a symbol of absolute aridity. But we know that just a few thousand years ago, it was a lush, green landscape crisscrossed with rivers and lakes, a period scientists call the African Humid Period. The prevailing explanation is that this was caused by a slight shift in the Earth's orbital axis, which increased monsoon rains. However, this transition from green to desert was not a slow, uniform process. Core samples from lake beds reveal that the greening happened remarkably quickly in some regions, and there's evidence of human settlements thriving in areas that should have been far more marginal. This has led some researchers, like archaeologist Dr. David Wright, to propose a fascinating alternative theory, that it wasn't just climate that allowed humans to flourish, but that humans themselves helped create and prolong that fertile period through deliberate land management. The theory suggests that early pastoralists may have used controlled burning to maintain savanna grasslands, which in turn increased the land's albedo or reflectivity, potentially helping to draw in more monsoon rains. When these societies eventually declined, the delicate balance they maintained could have collapsed, accelerating the desertification process. This flips the entire narrative, suggesting ancient societies weren't just adapting to their climate. They were active participants in its creation, and their collapse had direct, catastrophic environmental consequences. This idea of humans as active planetary engineers finds even more startling support deep within the Amazon rainforest. For centuries, the prevailing view was of a pristine wilderness, a natural paradise untouched by human hands. But that view is being radically overturned by the discovery of terra preta, literally black earth. Scattered across the Amazon basin are vast expanses of incredibly rich, dark soil, starkly contrasting with the region's naturally thin, nutrient-poor red clay. This isn't a natural geological formation. Terra preta is now understood to be a human-made soil, a masterpiece of ancient bioengineering created by centuries of intentional soil enrichment. It's a complex mixture of charcoal, bone, pottery shards, compost, and manure. This combination does something miraculous. It creates a self-regenerating, hyper-fertile soil that retains moisture and nutrients far more effectively than anything nature produces on its own in that environment. The presence of this engineered soil across thousands of square miles suggests a lost civilization of immense scale and sophistication that didn't just live in the Amazon. They actively built and cultivated it, transforming large swaths of the rainforest into a managed, productive food forest. They weren't passive inhabitants of a wilderness. They were its gardeners, using advanced agroecological knowledge to create a stable and abundant climate for agriculture on a continental scale. On an even grander scale, geologists are uncovering evidence of what can only be described as macro-engineering projects. There are river systems with courses that appear artificially straightened or redirected, suggesting a large-scale effort to control flooding or irrigate vast plains. In places like the Bolivian highlands, researchers have found complex networks of raised fields and canals surrounding ancient cities like Tiwanaku. These weren't just for irrigation. Studies have shown that these water channels created their own microclimates. The water absorbed heat during the day and released it at night, protecting delicate crops from the region's frequent frosts and effectively raising the local temperature by several crucial degrees. This is climate control on a community-wide scale, a technological solution to a severe environmental challenge. Perhaps the most compelling data comes from the world of paleoclimatology. Scientists like Dr. William Thompson analyze ice cores from glaciers and sediment layers from lake and ocean beds. These act as a historical record of Earth's climate, year by year for thousands of years. What some of these records show are periods of unusual climatic stability that directly coincide with the peak of powerful ancient civilizations. For example, during the height of the Roman Empire, the Mediterranean region experienced a sustained period of reliable, predictable weather that historians call the Roman climatic optimum. This wasn't just good luck. It's possible that the Romans' massive deforestation and intensive agriculture actually released enough greenhouse gases to slightly, but significantly, warm the European climate, creating more favorable conditions for their expansion. Similarly, the decline of many Mesoamerican cultures correlates with periods of extreme drought identified in sediment cores. The question is, did the climate change cause the collapse, or did the collapse of their sophisticated water management and forest conservation systems cause the climate to become more extreme? This chicken and egg dilemma forces us to confront the very real possibility that ancient civilizations had a measurable, lasting impact on global climate patterns long before the Industrial Age. These geological and environmental anomalies are the silent, enduring witnesses to a forgotten age of ecological mastery, urging us to look at the land not as a static backdrop to history, but as a canvas that our ancestors may have actively helped to paint. This deep connection to the sky goes far beyond simple stargazing. For ancient civilizations, the movement of celestial bodies wasn't just a spectacle. It was the ultimate clock, calendar, and forecasting tool, intricately woven into their very survival. By achieving an almost impossible level of astronomical precision, cultures like the Maya and the Egyptians developed the ability to predict not just the changing of the seasons, but the behavior of the climate itself. They could anticipate the life-giving arrival of monsoon rains or the devastating approach of a prolonged drought with remarkable accuracy. This wasn't magic, it was a sophisticated science of observation, a long-term data collection project carved into stone and passed down through generations. Their survival depended on reading the subtle cues written in the heavens, allowing them to prepare, adapt, and potentially even intervene in their environmental destiny. Consider the magnificent stone circles scattered across the British Isles, with Stonehenge as the most famous example. While its exact purpose is still debated, its precise alignment with the summer and winter solstices is undeniable. This alignment provided an incredibly accurate, immovable calendar. The specific angle of the sunrise on the winter solstice didn't just mark the shortest day of the year, it signaled the deepest point of cold, a critical turning point after which the sun would begin its slow return, and plans for the next planting season could cautiously begin. This knowledge was power. It allowed communities to time their agricultural cycles with nature's rhythm, ensuring seeds were sown exactly when the soil temperature and moisture were optimal, and harvests were gathered at the peak of ripeness before autumn rains could spoil them. This precise timing was a form of passive climate control, a way to maximize food security by harmonizing human activity with the predictable, celestial-driven patterns of the weather. But what if these alignments served a purpose even more active and profound than a calendar? some researchers propose a truly revolutionary idea, that these ancient monuments were not just observatories but functional devices, designed as energy collectors that could harness forces from the cosmos to directly influence the local environment. The unique shape of the pyramid, found in cultures across the globe from Egypt to Mesoamerica, is central to this theory. It's been suggested that the pyramid form can act as a natural resonator for the Earth's own subtle electromagnetic energy, a concept sometimes called telluric energy. Think of it like a tuning fork for the planet. By concentrating this energy, a large stone pyramid could theoretically create a localized effect on the atmosphere above it, perhaps influencing cloud formation, ionizing particles in the air, or even subtly altering barometric pressure. This wouldn't be about creating a thunderstorm on command, but about gently nudging the local climate towards greater stability, fostering conditions more favorable for agriculture and human habitation. This concept of a seamless integration between celestial observation and earthly application points to a holistic world view that we are only beginning to appreciate. Ancient engineers seem to understand that the Earth and the sky were not separate realms but a single, interconnected system. Their architectural marvels were designed to be the interface for this system. By aligning a temple doorway to capture the first ray of the sun on the equinox, they were perhaps doing more than marking a date. They could have been using that focused beam of light to heat a specific pool of water, triggering a convection current that would vent hot air from a chamber or draw cool air in from another passage, effectively regulating the building's internal climate. This is the ancient equivalent of a modern smart grid that responds to environmental cues, but powered entirely by an intimate knowledge of planetary and solar cycles. The potential of this celestial connection brings us right back to the heart of the storm vault mystery. If these vaults were real, their operation would have required perfect timing. You wouldn't activate a system designed to capture moisture from the air before the annual winds shifted to bring in dry desert air. You would wait for the specific celestial event that heralded the arrival of the humid season. The astronomical alignments we find at so many ancient sites may have been the activation codes, the on switches for these vast climate systems. The knowledge of the stars provided the when, and the architecture provided the how, creating a sophisticated technology that worked in concert with the natural world rather than against it, revealing a depth of understanding about our planet's place in a larger cosmic dance that we are still struggling to fully comprehend. Now we move from the silent alignment of the stars to something far more palpable and immediate: the power of sound. It's an idea that feels almost magical, but the science behind it is remarkably concrete. Everything in our universe, from the smallest atom to the largest planet, is in a constant state of vibration. Ancient cultures seem to understand this fundamental truth intuitively, and they may have learned to harness these vibrations in ways we are only just beginning to test with modern instruments. This isn't about fantasy, it's about physics. Specific sound frequencies have measurable effects on matter. We see it in the way a powerful bass note can make your chest resonate, or how an opera singer's sustained note can shatter a wine glass. Now scale that principle up. Imagine directing that same vibrational energy not at a glass, but at the atmosphere itself, at the clouds, the moisture in the air, the very pressure systems that dictate our weather. The archaeological record is filled with tantalizing clues that point to this practice. Step inside the Great Pyramid of Kukulkan at Chichen Itza. If you clap your hands once at the base of the massive staircase, the structure doesn't just create an echo. It returns a piercing, chirping sound that perfectly mimics the call of the sacred Quetzal bird. This is no accident. It's a meticulously engineered acoustic effect, demonstrating a profound understanding of sound wave reflection and resonance. But what was its purpose? Was it purely ceremonial, or could that concentrated sonic energy have had a wider environmental function? Journey across the Atlantic to the Neolithic sites of Ireland, and you'll find the famous humming stones of the Ring of Brodgar. These massive, standing stones emit a low, persistent hum when the wind passes over them at a certain speed and angle, a natural phenomenon that would have been both eerie and inspiring to ancient peoples. It's not difficult to imagine them experimenting, perhaps adding their own voices or instruments to this natural chorus, learning through observation which combinations of sounds seem to correlate with changes in the weather. These ancient experiments find a startling parallel in modern laboratory research. Scientists like Dr. Elizabeth Hagen have been studying the effects of infrasound, low-frequency sound waves below the range of human hearing, on atmospheric conditions. In controlled settings, applying specific sonic frequencies to chambers filled with water vapor has been shown to encourage the rapid coalescence of droplets, effectively seeding the beginnings of cloud formation. Other experiments have demonstrated that certain frequencies can influence air pressure zones on a small scale. This isn't science fiction, it's acoustical physics. It suggests that the legend of Orpheus using his lyre to calm stormy winds and charm the stones themselves might be one of history's most elegant metaphors for a lost technology. Perhaps his music was not mere melody, but a precise, applied frequency that interacted with the turbulent air, restoring calm through a science that later generations could only explain as divine magic. This vibrational approach to environmental management represents a philosophy that is incredibly relevant today. Unlike our modern methods, which often rely on brute force chemical cloud seeding or energy-intensive geoengineering projects, an acoustic system would be inherently non-invasive and potentially energy efficient. It works with the natural resonant frequencies of the environment rather than overwhelming it. This principle of harmony is something still practiced in various indigenous traditions around the world. Certain Native American tribes use specific drumming patterns in ceremonies intended to call for rain, and half a world away, Aboriginal communities in Australia use the deep, resonant tones of the didgeridoo in rituals connected to the weather. For millennia, these practices have been dismissed by Western science as superstition. But what if we've been misinterpreting them? What if they are not pleased to the gods but the preserved, ritualized remnants of a sophisticated practical science? The ceremony ensures the knowledge is passed down, the specific rhythms and tones are remembered, and the community participates in a collective action that may have a genuine physical effect on their environment. As we open our minds to this possibility, we begin to see a beautiful synthesis of art and science in the ancient world. The line between the shaman and the engineer, the temple and the laboratory, blurs into irrelevance. The goal wasn't to dominate nature, but to converse with it, to find the right note, the correct frequency that would bring the atmosphere into a state of balance. In an era where our own environmental interventions often have catastrophic unintended consequences, this ancient model of a subtle, resonant, and harmonious technology offers a profoundly different path forward. It challenges us to listen, not just with our ears but with our whole scientific being, to the forgotten songs of the past, to the hum of the stones, and to the possibility that the most powerful tool for shaping our world might not be a massive machine, but a perfectly pitched vibration. Water represents the very lifeblood of civilization, and no society could thrive without mastering its flow. Yet what we are beginning to understand is that ancient hydroengineering may have reached far beyond simple irrigation or supplying drinking water. These systems appear to have been designed with a grander, more holistic purpose, to actively shape and moderate the very climate itself. The Romans are famed for their magnificent aqueducts, stone arteries that carried water across impossible distances, but their impact may have been more than just utilitarian. By channeling vast quantities of water into large, open reservoirs within their cities, they weren't just creating storage, they were building massive heat sinks and evaporation engines. The constant evaporation from these surfaces would have noticeably cooled the surrounding air, creating a more comfortable microclimate in the sweltering Italian summers, and potentially even influencing local humidity levels to a degree that could affect rainfall patterns. This was climate control on an urban scale, a deliberate use of hydrologic principles to engineer a more habitable environment. This sophisticated understanding of water's role in temperature regulation finds even more dramatic expression in the ancient underground cities of Turkey, such as Derinkuyu or Kaymakli. These sprawling subterranean complexes carved deep into the soft volcanic rock are engineering marvels, but their most ingenious feature might be their hidden water networks. Deep wells tapped into groundwater, and these channels did more than just provide a secret water source during a siege. They functioned as a natural geothermal cooling system. The Earth at that depth maintains a remarkably constant, cool temperature year-round. As air circulated through the vast network of tunnels and past these water channels, it would be naturally cooled and humidified in the summer and gently warmed in the winter. This wasn't just a refuge from invaders, it was a climate-controlled sanctuary from the extreme heat and cold of the Anatolian plateau, a testament to an intuitive grasp of thermodynamics that we would only formalize millennia later. Perhaps nowhere is the multifunctional genius of ancient water management more spectacularly displayed than at Angkor Wat in Cambodia. The entire complex is surrounded by a massive moat nearly 200 meters wide. While it certainly served a defensive purpose, its primary role was likely climatic and symbolic. This enormous body of water acted as a massive stabilizer for the temple complex. During the intense heat of the day, the water would absorb solar radiation, preventing the immediate stone surroundings from becoming unbearably hot. At night, it would slowly release that stored heat, mitigating the coolness. This process created a stable microclimate that would have protected the intricate sandstone bas-reliefs from the damaging effects of extreme temperature fluctuations, preserving them for centuries. Furthermore, the vast network of canals and barrays or reservoirs surrounding Angkor functioned as a complex hydraulic system that managed the region's intense monsoon rains, prevented flooding, stored water for the dry season, and through evaporation, likely contributed to the region's humidity, supporting the lush vegetation that envelops the ruins today. This was a landscape entirely engineered for balance, where water was the primary tool for maintaining ecological and architectural harmony. In the arid landscapes of Persia and the Indian subcontinent, we find another breathtaking innovation, the stepwells and qanats. The qanats of Persia are gently sloping tunnels dug into alluvial fans, channeling water from mountain aquifers down to the arid plains below without a single pump, relying entirely on gravity. This not only provided a reliable water source but also brought cool, moist air from the underground water table flowing into the hot, dry cities. The stepwells of India, like the magnificent Rani Kai Vav, are architectural wonders that descend deep into the earth. Their design was as much about climate as it was about water access. As one descended the steps, the air would become progressively cooler and more humid, offering a respite from the blistering surface heat. The intricate carvings and vast, open shafts also facilitated air circulation, creating a natural cooling effect. These structures were public gathering places, community centers built around the principle of using water to create a comfortable microclimate, seamlessly blending practical engineering with social and spiritual life. They demonstrate that the ancient mastery of water was not a separate technical discipline, but was utterly woven into the cultural fabric, a cornerstone of a philosophy that saw humanity not as separate from nature, but as a conscious participant in its cycles, capable of crafting pockets of stability and abundance within even the most challenging environments. High on the arid plains of southern Peru, the Nazca lines have captivated and mystified the world for decades. These enormous geoglyphs, etched into the desert floor, depict everything from spiders and monkeys to intricate geometric shapes, some stretching over 200 meters across. The conventional explanation has long pointed toward ritual or astronomical purposes, perhaps a celestial calendar or sacred pathways for ceremonial walks. But what if we've been missing a crucial, more practical dimension to these vast earthworks? What if these lines were not meant to be seen from above by gods, but to be felt and experienced on the ground as part of a sophisticated climate management system? The environment the Nazca people called home is one of the most demanding on Earth, a desert where rainfall is scarce and unpredictable. Survival here would have required an intimate and ingenious understanding of how to coax water from a seemingly barren landscape. This is where a fascinating theory takes root. The desert pavement, the top layer of the Nazca plain, is covered with dark, reddish-brown stones rich in iron oxide. By removing these stones to reveal the lighter, sandy soil beneath, the Nazca artists didn't just create contrasting images, they may have been creating a massive thermal engine. Dark surfaces absorb heat while light surfaces reflect it. On a vast scale, this deliberate contrast could have engineered the local atmosphere itself. The dark stones along the edges of the lines would heat up rapidly under the intense desert sun, warming the air immediately above them and causing it to rise. This rising hot air would then draw in cooler, moisture-laden air from the surrounding areas and from underground aquifers, a process similar to how a chimney creates draft. This constant, gentle movement of air could have had a profound effect on the microclimate. The ultimate goal of this engineered airflow may have been dew capture, a critical source of water in many arid environments. As the warmer, moisture-bearing air was drawn across the cooler, lighter-colored surfaces of the lines themselves, the temperature drop could have caused water vapor to condense directly out of the air, forming life-giving dew. This would explain the curious presence of countless small piles of stones placed carefully alongside many of the figures. These stone mounds or apashatas might not be random ritual offerings but functional components of the system, acting as additional heat sinks to enhance condensation or as markers for maintaining the system. In a place where every drop of water is precious, this daily harvest of dew could have been the difference between life and death for crops, providing just enough moisture to sustain agriculture in this harsh environment. This theory transforms how we view the specific glyphs. The famous hummingbird, with its long, pointed beak, might align with the direction of seasonal winds that brought humid air from the Pacific Ocean or the Andes Mountains. The colossal spider glyph could be a symbolic representation of water divination, as some species of spider are known to detect minute changes in humidity. Even the straight lines and trapezoids, which seem less artistic, could have served as the primary functional elements, vast funnels designed to channel and accelerate these manufactured breezes toward specific collection points or agricultural zones. The entire desert floor becomes a readable blueprint, a complex circuit board designed to interact with the very elements. Modern technology is now providing startling support for this once fringe idea. Researchers using drones equipped with thermal imaging cameras have flown over the lines at dawn. Their findings are remarkable. The areas where the dark stones have been removed cool down at a different rate than the surrounding desert pavement. This creates a thermal differential exactly at the time when dew formation is at its peak, suggesting the lines were actively managing temperature to optimize water condensation. This isn't just a static drawing, it's a dynamic system that interacts with the daily cycle of the sun. Furthermore, the discovery of extensive ancient aqueducts, known as puquios, running beneath the Nazca plain proves that this culture possessed advanced hydroengineering knowledge. These spiral-shaped stone wells tapped into underground water sources, and their construction shows a deep understanding of how to access and manage subsurface water. The lines on the surface and the aqueducts below were likely part of one integrated, brilliant strategy for survival, a testament to a civilization that didn't just endure its environment, but learned to gently persuade it to provide. Of all the ancient structures that capture our imagination, none stands taller or sparks more debate than the Great Pyramid of Giza. For centuries, its primary purpose has been accepted as a monumental tomb for a powerful pharaoh. But what if that's only a fraction of the story? What if this incredible edifice was also a sophisticated machine, designed not just to house the dead, but to interact dynamically with the very forces of nature? This idea pushes us to look beyond the traditional narrative and consider the pyramid not as a silent tomb, but as a potential hub of ancient environmental technology, a central component in a network of storm vaults. The precision of its construction is the first clue that there's more here than meets the eye. The pyramid's near-perfect alignment to the cardinal directions north, south, east, and west is an astonishing feat of engineering. While this is often discussed in spiritual or astronomical terms, the practical implications are profound. This specific orientation would have allowed the structure to interact in a very specific way with the prevailing wind patterns of the Giza Plateau. The north face, for instance, might have been positioned to channel cool northern breezes, while the shape itself could have been designed to deflect the harsh, sand-laden winds of the desert, reducing erosion and sand accumulation around the complex. This isn't random, it's architecture that responds directly to its environmental context. Then we step inside, and the mystery deepens significantly. The King's Chamber, built from massive blocks of solid red granite, has long been noted for its remarkable and stable temperature. While the desert outside swings dramatically between scorching days and chilly nights, the interior of this chamber remains at a constant, cool temperature. Granite is rich in quartz crystals, a mineral known for its piezoelectric properties, meaning it can generate a small electrical charge when subjected to pressure or vibration. Could the constant, subtle vibrations of the earth itself, or even the sound waves from ritual chants within the chamber, have caused these stones to generate a low-level energy field? Furthermore, the chamber's acoustic properties are unusual. Sounds within it resonate and amplify in specific ways. Some researchers have proposed that these precise sonic frequencies could have been used to influence atmospheric conditions, perhaps by agitating ions in the air or affecting local humidity in a way that modern science is only beginning to understand. This theory of a climate-controlled plateau finds unexpected support from the Great Sphinx, the pyramid's silent guardian. Geologists like Dr. Robert Schoch have pointed to the pronounced erosion patterns on the Sphinx's body and its enclosure, which they argue resemble weathering caused by prolonged, heavy rainfall, not just wind and sand. This type of erosion would suggest the Sphinx is far older than traditionally believed, dating back to a time when the climate of Egypt was much wetter. But another interpretation exists. What if the erosion wasn't from a forgotten climatic age, but was the result of a deliberate and concentrated water management system? If the Giza complex was designed to moderate the climate, it might have involved sophisticated water channels and collection systems to harness the rare but powerful desert rains. The runoff from such a system, directed and controlled over centuries, could potentially account for the unique water-like weathering on the Sphinx, suggesting it was part of an active, functioning environmental engine, not merely a passive statue subjected to the elements. When we turn to the sacred texts of ancient Egypt, we find descriptions that seem to support this technological interpretation. The pyramids are often described not as silent tombs, but as living entities connected to natural forces. Texts speak of the breathing of the gods and the winds of creation emanating from these structures. These phrases have typically been interpreted as pure mythology. But what if they are metaphorical descriptions of a real physical process? The breathing of the gods could be a poetic way to describe the movement of air through the pyramid's internal passageways, air that is being cooled, heated, or otherwise modified. The winds of creation might refer to the outcome of this process, the gentle, beneficial breezes that were directed across the plateau to moderate the harsh desert climate, making the area more habitable and fertile. Imagine the entire Giza plateau not as a necropolis, a city of the dead, but as a vast, sacred power plant for environmental balance. The Great Pyramid at its heart could have functioned as a central regulator. Its shape might have acted as a lens to focus and amplify the Earth's natural energies. Its internal chambers could have been tuning forks, using sound to stabilize atmospheric pressure. Its alignment and surrounding structures, including the Sphinx, may have worked in concert to manage water resources and direct airflow, perhaps even to influence the behavior of the nearby Nile River, mitigating floods or attracting rain clouds. This perspective doesn't necessarily negate its role as a tomb. In Egyptian belief, the pharaoh was the intermediary between the gods and the people. What better place for him to reside in the afterlife than at the very heart of the machine that sustained his kingdom, ensuring its harmony and prosperity for eternity? While this theory remains controversial and is far from mainstream acceptance, it challenges us to expand our understanding of ancient genius, connecting their architectural mastery to a profound ecological wisdom that saw humanity not as separate from nature, but as an active participant in its delicate balance. Plato's account of Atlantis stands as one of history's most tantalizing enigmas, not merely as a story of a sunken island, but as a potential blueprint for a civilization that mastered its environment. In his dialogues Timaeus and Critias, written around 360 B.C.E., Plato describes Atlantis not as a primitive society, but as an advanced empire of immense power and sophistication. Its capital city was arranged in concentric rings of land and water, connected by grand canals and bridges, a layout that suggests more than just architectural beauty. This design mirrors modern concepts of integrated water management and hydraulic engineering, potentially capable of regulating tides, managing storm surges, and creating a stable, temperate microclimate across the entire kingdom. According to Plato, the Atlanteans did not just build cities, they harnessed the very forces of nature, creating a utopian society that flourished for centuries until it was lost in a single cataclysmic day and night. Central to many modern reinterpretations of this story is the intriguing detail of Atlantean power sources. Ancient texts and later esoteric traditions speak of the Atlanteans using what they called great crystals or energy stones to manipulate weather and prevent natural disasters. These crystals were said to be housed in special temples or towers where they would gather and focus energy from the sun, the earth, or even subtle atmospheric forces. While this sounds like pure fantasy, we can look to the natural properties of certain minerals for a possible scientific basis. Quartz crystals, for example, are piezoelectric. They generate a small electrical charge when subjected to mechanical pressure. On a large scale, strategically placed and precisely oriented crystals could theoretically interact with the Earth's magnetic field or atmospheric static electricity, perhaps even influencing cloud formation or ionizing the air to encourage rainfall. This wouldn't be magic. It would be an advanced application of principles we are still exploring today in fields like atmospheric science and renewable energy. What makes the Atlantis narrative so compelling is that it is not an isolated story. Strikingly similar accounts appear in the myths and histories of other ancient cultures, suggesting a possible shared memory of a lost technological age. In the Hindu epics, the Ramayana and Mahabharata, there are detailed descriptions of the Rama Empire and its magnificent flying machines, the Vimanas. These texts don't just say they could fly, they describe them as vehicles capable of influencing the weather, of creating artificial clouds for concealment, or of summoning rains to end a drought. Half a world away, the Aztecs and Mayans spoke of their ancestors coming from a lost island paradise called Aztlan or Tolan, a place of immense knowledge that was also lost to the sea. These parallel narratives from cultures that had no known contact with each other point toward a common theme, a golden age of advanced knowledge that ended in a great deluge. This idea moves from the realm of pure myth into the realm of plausible history when we consider the growing body of archaeological evidence for sophisticated lost civilizations. The discovery of the Antikythera mechanism, an ancient Greek analog computer used to predict astronomical positions and eclipses, proves that the ancient world was capable of technological complexity we never imagined. Furthermore, marine archaeologists are continually discovering the ruins of submerged cities off the coasts of India, Japan, and in the Mediterranean. Sites like Dwarka in India or the Yonaguni Monument off the coast of Japan show clear evidence of human carving and construction, now lying deep underwater, confirming that vast stretches of coastal land were indeed swallowed by the rising seas at the end of the last ice age. These are not the streets of Atlantis itself, but they are proof that cataclysmic flooding did erase entire chapters of human history from the map. Researchers like Dr. Graham Hancock have built compelling careers on this very premise, that these widespread flood myths are not fictional stories but cultural memories of a real, catastrophic event that wiped out advanced prehistoric societies. He and others propose that these societies possessed a deep understanding of the natural world, including climate engineering systems that allowed them to thrive. Their downfall, therefore, might not have been a simple act of God or nature, but a catastrophic failure of their own technology. Perhaps their interventions in the climate created an unforeseen feedback loop, or a shift in the Earth's crust, possibly linked to the same cometary impacts or meltwater pulses that ended the Ice Age, disrupted their delicate systems with devastating consequences. This exploration of Atlantis and other lost worlds forces us to confront a profound and urgent ethical question. The story serves as a powerful allegory for our own time. We are now living in an age where human activity is undeniably and dramatically altering the global climate. We are debating the ethics and perils of geoengineering, proposals to spray reflective particles into the atmosphere to block sunlight, or to fertilize the oceans to absorb more carbon. The legend of Atlantis, then, becomes the ultimate cautionary tale. It reminds us that the power to control the climate comes with immense responsibility and even greater risk. Their supposed hubris, their attempt to dominate nature rather than live in harmony with it, is presented as the cause of their downfall. As we stand on the brink of deploying our own global climate technologies, the ghost of Atlantis urges us to proceed with humility, to prioritize balance over domination, and to ensure that in our quest for control, we do not unleash the very forces that could lead to our own collapse. This lost civilization challenges us to learn from its imagined mistakes, making its story not just a historical mystery, but a critical mirror for our modern planetary dilemma. While our journey has taken us through grand ruins and deciphered ancient texts, some of the most powerful evidence for the principles behind the storm vaults isn't buried in the past. It's alive and thriving in indigenous communities around the world today. These cultures serve as a living bridge, offering a direct window into a way of thinking about our environment that the modern world has largely forgotten. A philosophy where humanity is not a separate force to conquer nature, but an integral participant within its delicate systems. Their enduring practices provide a tangible, working model for how ancient civilizations might have approached climate engineering, not with brute force technology, but with subtle, observant, and deeply respectful intervention. Consider the profound wisdom of controlled fire. For generations, many Native American tribes have practiced what is known as cultural burning. Unlike the catastrophic wildfires we see today, which are often the result of decades of fire suppression leading to immense fuel buildup, these were carefully timed, low-intensity burns. They understood that fire was not merely a destructive force but a vital tool for renewal. These intentional fires would clear out dry underbrush, reducing the risk of uncontrollable blazes, while also returning nutrients to the soil and encouraging the growth of specific, fire-resistant plant species that provided better food and materials. This wasn't just land management, it was a form of large-scale ecosystem engineering. They were actively shaping the landscape to be more resilient, more productive, and safer for all its inhabitants, demonstrating a sophisticated understanding of ecological balance that we are only now beginning to relearn in our fight against modern megafires. This same philosophy of working with elemental forces is echoed half a world away in Australia, where Aboriginal peoples have practiced firestick farming for over 50,000 years. By strategically burning country in a mosaic pattern, they didn't just prevent larger fires, they managed the very climate of their region on a macro scale. The resulting patchwork of vegetation at different stages of growth created diverse microclimates, influenced local humidity, and could even encourage the formation of rain clouds by altering the heat reflectivity of the land. Their intricate knowledge, passed down through songlines and story, encoded precise information on when, where, and how to use fire to maintain the health of the entire continent. This practice shows a breathtakingly long-term perspective on environmental stewardship, viewing themselves as custodians responsible for maintaining the balance of life, a core principle that must have underpinned any ancient climate control system. In the high Andes of Peru, the Quechua people continue to cultivate crops on breathtakingly steep slopes using agricultural terraces that are centuries, if not millennia, old. These are not simple stone walls, they are a complex climate-regulating technology. The terraces do more than just prevent erosion. They create a series of microclimates. The higher, sun-drenched terraces are perfect for sun-loving crops like maize, while the lower, shaded, and more humid terraces are ideal for potatoes and other tubers. The stone walls absorb heat during the day and release it slowly at night, protecting delicate plants from frost. Sophisticated irrigation channels, fed by glacial meltwater, weave through this system, ensuring even water distribution and maintaining constant humidity that moderates the arid mountain air. This entire man-made landscape functions as a highly stable, self-regulating agricultural system that has sustainably fed populations in an incredibly challenging environment for generations, a testament to an engineering genius focused on long-term harmony. Travel to the Bandiagara escarpment in Mali, and you will find the Dogon people, whose astronomical knowledge has fascinated researchers for decades. Their understanding of the Sirius star system is remarkably precise, but their earthly wisdom is equally profound. The Dogon practice a form of sustainable agriculture that is perfectly adapted to their semi-arid environment. They utilize complex planting patterns that maximize water retention and soil health, and they have developed sophisticated soil management techniques using organic materials to create fertile pockets of land in the rocky terrain. Their entire societal structure and spiritual beliefs are interwoven with the cycles of nature, viewing the land not as a resource to be extracted, but as a sacred partner in a reciprocal relationship. This holistic worldview, where celestial cycles inform earthly practice, mirrors the likely mindset of the ancient builders we've been discussing, for whom technology and spirituality were two sides of the same coin. The true power of this indigenous knowledge is being unlocked through a new and respectful collaboration between modern scientists and traditional elders. Researchers in fields like agroecology and climatology are now partnering with indigenous communities, not to study them as subjects, but to learn from them as colleagues. Together, they are validating the efficacy of these ancient techniques with modern data, measuring the carbon sequestration benefits of cultural burns or the biodiversity increases in traditionally managed forests. This partnership is revealing that these practices are not quaint traditions but highly sophisticated, empirically derived systems of environmental management. They offer a treasure trove of proven, low-tech, and adaptable solutions to contemporary problems like desertification, soil depletion, and climate resilience. This living library of knowledge fundamentally reframes our understanding of the storm vaults. It suggests that these ancient systems were likely not standalone technological marvels operating in isolation, but rather the most visible and monumental expressions of a much broader and deeply ingrained cultural ethos. This ethos viewed the world as an interconnected whole where every action had a reaction, and where the goal of engineering was not to dominate nature, but to gently guide it, to collaborate with it, and to find a sustainable balance that would ensure the flourishing of all life for generations to come. In honoring and learning from these living traditions, we don't just uncover clues about the past, we find a hopeful and practical path forward, one that integrates ancient wisdom with modern innovation to address the greatest environmental challenge of our time. So how do we move beyond compelling theories and into the realm of verifiable fact? The answer lies in a fascinating and hands-on field of research known as experimental archaeology, where scientists and historians are literally rebuilding the past to test its potential. This isn't about guesswork, it's about constructing full-scale replicas of ancient structures, using period-appropriate tools and materials, and then meticulously measuring the results with the most advanced modern instruments. The goal is to bridge the gap between the theoretical and the tangible, to see if these concepts actually function as proposed. One of the most successful examples of this comes from the study of ancient Persia's wind catchers, or badgers. Research teams in Iran and at institutions worldwide have constructed precise replicas of these iconic towers, often attaching them to model homes or test chambers. Using sensitive thermometers and anemometers, they have been able to quantify their incredible efficiency. The data is startling. These passive systems, with no moving parts and requiring zero energy input, can consistently lower interior temperatures by up to 10 degrees Celsius compared to the outside air. This isn't just a minor comfort, it's a transformative technology that could turn a scorching desert dwelling into a livable space, validating ancient descriptions of palaces that remained cool even in the height of summer, and proving that what we might call climate control was not only possible but widely implemented. The experimentation extends far beyond architecture and into the more ethereal realm of sound. Inspired by persistent legends and the peculiar acoustic properties of ancient sites, researchers are venturing into deserts and highlands with a new kind of instrument. Armed with powerful speakers capable of emitting very low frequencies, often those below the range of human hearing, known as infrasound, scientists are conducting field tests to see if these vibrations can physically interact with the atmosphere. Early, small-scale experiments have yielded intriguing, albeit preliminary, results. In some trials, applying specific sonic frequencies to patches of fog has been shown to encourage the tiny water droplets to coalesce and fall, effectively dispersing the fog in a localized area. Other projects are investigating whether sustained, resonant sound waves can influence the formation of clouds or even encourage the gentle turbulence needed to trigger rainfall in arid regions. While these modern experiments are in their infancy, they lend a remarkable degree of credibility to those ancient myths of priests and shamans who used chants, drums, and horns to call forth the rain or calm a storm. It suggests that these stories may be the cultural memory of a refined science, a practice of using the physics of vibration to gently persuade the weather. Crucially, this detective work isn't limited to what we can see on the surface. Some of the most exciting breakthroughs are happening underground, thanks to advanced remote sensing technologies that allow us to peer into the earth without ever lifting a shovel. Light detection and ranging, or LiDAR, is being deployed over dense jungle canopies and vast archaeological sites, using laser pulses to strip away vegetation and reveal the ghostly outlines of ancient cities, complete with their elaborate water channels, reservoirs, and road systems. This technology has been revolutionary at sites like Angkor Wat, showing us the true scale of their hydraulic network. Similarly, ground-penetrating radar is being used to map the subterranean world beneath sites like the Nazca Plains or the Giza Plateau. These radar waves can detect anomalies, voids, tunnels, changes in soil density, or buried stonework that hint at extensive underground complexes. Researchers are now identifying what appear to be vast resonance chambers beneath temple floors, networks of pipes that may have carried water or air, and hidden channels that could have been part of a larger climate regulation system. These tools are providing the blueprints for structures we never knew existed, revealing that the ancient world may have been just as complex below ground as it was above. What makes this entire endeavor so profound is the unique collaboration. It represents a true dialogue between the ancient and the modern. We are using 21st century supercomputers to model the airflow through a 2,000-year-old wind tower. We are employing million-dollar satellite arrays to confirm the accuracy of a celestial alignment first observed with the naked eye and a stone circle. This fusion of cutting-edge science with ancestral wisdom does more than just provide empirical data. It fosters a deep sense of respect for the ingenuity of ancient engineers. They operated without our resources or our formal scientific language, yet they achieved a level of sophistication and sustainability that we are only now beginning to fully appreciate. Their solutions were elegant, energy-efficient, and built to last for millennia. By testing their methods, we are not just solving a historical puzzle, we are actively reviving a lost arts cabinet of sustainable technologies. Each successful experiment offers a potential alternative to our own energy-intensive systems of air conditioning, irrigation, and weather modification, reminding us that the path to a greener future might be found by looking back at the brilliant innovations of our shared past. If ancient civilizations truly possessed the ability to shape their weather and climate, their legacy offers us far more than just a fascinating historical puzzle. It presents a critical mirror for our own modern environmental crisis. The most striking contrast lies in the fundamental philosophy that seemingly guided their efforts. Where our industrial-era interventions often rely on brute force extraction and fossil fuels, their methods appear rooted in a profound synergy with natural systems. They didn't fight against the wind, they channeled it through cleverly designed towers. They didn't overpower rivers with concrete dams, they gently guided water through gravity-fed underground canals. This approach utilized locally sourced, biodegradable materials, stone, earth, water, and air operating within the planet's existing energy budgets without generating the pollution or resource depletion that defines our current predicament. This suggests a world view where humanity was not a separate force meant to dominate nature, but an active participant within a delicate, interconnected web of life, a perspective we are now desperately trying to reclaim. This ancient model of sustainability provides a powerful blueprint for our own technological development. Imagine applying these principles to modern green architecture. Instead of energy-hungry air conditioning units, we could design buildings with passive cooling systems inspired by Persian wind catchers, dramatically reducing our electricity demand. Instead of vast, centralized water treatment plants that consume enormous power, we could implement decentralized, biomimicry-based filtration systems modeled on the natural purification processes observed in ancient wetland-based settlements. Their success demonstrates that long-term resilience isn't necessarily born from complexity and high-energy input, but from elegant, adaptive design that works in concert with local environmental conditions. This shift in thinking from overpowering nature to partnering with it could be the most valuable lesson we extract from the past, guiding the development of technologies that are not just efficient, but inherently restorative and harmonious. Yet for all its inspirational value, this history also comes with a stark and sobering warning. The very legends that hint at this advanced knowledge, like the story of Atlantis, often culminate in catastrophic failure and collapse. These narratives can be read as poignant allegories for the dangers of hubris, of overestimating our understanding and overreaching in our manipulation of incredibly complex planetary systems. It forces us to ask a difficult question. Did some of these ancient climate systems themselves contribute to their own downfall? Could extensive deforestation to create terraced farms have altered regional rainfall patterns? Could large-scale water diversion for grand irrigation projects have inadvertently salinized the soil or drained aquifers faster than they could recharge? The lesson here is not that we should abandon innovation, but that we must approach geoengineering with profound humility, rigorous precaution, and a deep acknowledgement of the law of unintended consequences. This duality between inspirational model and cautionary tale provides a crucial ethical framework for our own burgeoning field of climate engineering. As we debate proposals like injecting reflective aerosols into the stratosphere to block sunlight or fertilizing the oceans to spur carbon-absorbing algae blooms, the ancient perspective urges a principle of adaptation over domination. It argues for solutions that are localized, reversible, and modeled on natural processes rather than global, irreversible, and purely technological fixes. Furthermore, it highlights the vital importance of community involvement and indigenous knowledge. The construction and maintenance of ancient systems like the Nazca lines or the Kanat networks were likely collective endeavors rooted in the needs and wisdom of the local population. This stands in sharp contrast to the top-down, often corporate-driven proposals of today, reminding us that true sustainability must be democratically guided and culturally integrated to be truly successful and just. Ultimately, the mystery of the storm vaults challenges us to redefine progress itself. Our modern narrative often equates advancement with an increasing ability to control and insulate ourselves from the natural world. But this ancient paradigm suggests that true sophistication might lie in the opposite direction, in cultivating a deeper sensitivity to natural rhythms and developing a more nuanced, responsive relationship with our environment. Their innovation was not measured in megawatts of output but in generations of stability and balance. As we stand at a crossroads in our relationship with the planet, their example offers a path forward that is both visionary and deeply humble, urging us to build a future where our technologies don't just serve humanity, but actively heal and enhance the living world we are a part of. It's only natural to approach a concept as grand as ancient climate control with a healthy dose of skepticism. After all, extraordinary claims require extraordinary evidence, and many conventional historians and archaeologists rightly caution against interpreting every architectural wonder or weather-related myth as proof of a lost technology. The most common counterargument is one of coincidence, that the alignment of a structure with a solstice or a prevailing wind is simply a happy accident, a product of trial and error rather than sophisticated design. Similarly, the rich tapestry of global mythology is often explained away as purely symbolic, a way for pre-scientific cultures to personify the terrifying and unpredictable forces of nature through stories of gods and heroes, not a coded record of applied science. This skeptical viewpoint serves a vital purpose. It acts as a necessary filter, demanding rigor and preventing us from seeing patterns where none exist. Engaging with these critiques isn't a weakness. It's the very foundation of building a credible investigation. However, when we move from examining isolated pieces of evidence to analyzing the entire mosaic, the argument for mere coincidence begins to strain under its own weight. Consider the city of Mohenjo-Daro in the Indus Valley. Its existence wasn't just a happy accident of location. The entire urban plan, from the precise, grid-like streets to the uniformly sized bricks used in construction, reveals a society obsessed with standardization and mathematical precision. Most telling is their breathtakingly advanced water management system. Every single house had its own bathing area and was connected to a covered, city-wide drainage network. This isn't something that evolves through random chance. It is the product of centralized planning and a deep, intentional understanding of hydrology and public health. The goal was clearly stability, creating a resilient urban environment that could withstand seasonal floods and maintain sanitation for a large population. This level of deliberate engineering for environmental control makes it far less of a leap to suggest they might have applied similar ingenuity to the atmosphere above their city. Beyond the archaeological record, we now have the ability to test these ancient techniques in the modern world, and the results are often undeniable. Experimental archaeologists have built full-scale replicas of Persian wind catchers, using only tools and materials available at the time. When monitored with sensitive modern instruments, these structures consistently demonstrate an ability to lower interior temperatures by up to 10 degrees Celsius through passive ventilation alone. This is not a theoretical benefit, it is a measurable, repeatable climatic effect. Similarly, studies of ancient Andean terrace farming have shown that the complex system of stone walls and irrigation channels does more than prevent erosion. It actively creates a series of stable microclimates, with the stones absorbing heat during the day and releasing it at night to protect crops from frost, a deliberate and highly effective form of agricultural climate control. These aren't just clever ideas, they are proven technologies with observable impacts, moving the discussion from the realm of "could they" directly into the realm of "they did." The true power of this argument, however, lies in its interdisciplinary nature. A myth about a rain-making ritual studied in isolation by a folklorist might indeed be dismissed as symbolism. An oddly aligned temple, examined only by an architect, could be seen as aesthetically motivated. a layer of unusually rich soil in the Amazon, analyzed solely by a geologist, might be classified as a unique natural formation. But when the folklorist, the architect, and the geologist compare notes, a different story emerges. The myth describes a ritual performed at a specific temple alignment during a certain season. The architect confirms the temple's orientation captures winds that bring seasonal rains. The geologist identifies the soil as human-made terra preta, engineered to retain that very moisture for agriculture. This convergence of evidence from disparate fields creates a consistent and compelling pattern that is incredibly difficult to explain away as a series of unrelated coincidences. It suggests a holistic ancient world, where science, spirituality, and survival were seamlessly integrated. This isn't to say that every single theory about the storm vaults will ultimately prove correct. The pursuit of knowledge requires us to be open to the possibility that some ideas, no matter how appealing, might not withstand rigorous scrutiny. The goal isn't to replace one dogmatic view with another, but to foster a spirit of open-minded inquiry. By seriously considering the cumulative weight of evidence, the precise engineering, the replicable results, and the interconnected patterns across disciplines, we elevate the discussion beyond pseudoscience and into a legitimate field of scientific and historical exploration. Engaging with skepticism doesn't weaken the case for ancient climate engineering. It strengthens it, forcing us to refine our questions, seek better evidence, and build a more robust and credible understanding of our ancestors' true capabilities, ensuring that this fascinating mystery is explored with the rigor and respect it truly deserves. To truly unlock the secrets of the storm vaults, we can't rely on just one type of expert. This isn't a puzzle that fits neatly into a single academic box. It demands a grand collaboration, a meeting of minds from fields that don't always speak the same language. Imagine a round table where a climatologist, an archaeologist, a physicist, and an anthropologist all sit down together, each bringing a unique piece of the puzzle. The climatologist arrives with data from deep ice cores drilled in Greenland and Antarctica. These frozen time capsules contain tiny bubbles of ancient air and layers of dust that tell a precise story of what Earth's atmosphere was like thousands of years ago. They can identify periods of unusual climatic stability, like a 200-year stretch of perfect rainfall patterns in a region that should have been prone to drought. The crucial question they ask is, did this remarkable stability just happen to coincide with the peak of a great civilization, or could it have been the intended result of one? Meanwhile, the archaeologist is on their hands and knees at a dig site, carefully brushing dust from a strange, funnel-shaped artifact made of ceramic and stone. It doesn't look like a pot or a weapon. Could it be part of an apparatus for directing wind or collecting condensation? Nearby, they uncover a stone tablet with inscriptions that don't just praise a rain god, but seem to describe a specific ritual involving chanting at a certain frequency near a particular rock formation when the star Sirius rises. This isn't just a prayer, it reads like a technical manual. The archaeologist provides the physical evidence, the tools, the structures, the inscriptions that moves the theory from pure speculation into the realm of tangible possibility. Then the physicist takes that ceramic artifact and the description of the chant. In their laboratory, they use computer models to simulate the acoustic properties of the object. What frequency does it resonate at when air is blown through it? They test that frequency in a cloud chamber to see if it has any effect on water vapor. At the same time, they analyze the mineral composition of stones from ancient temple sites, modeling how they might interact with Earth's natural magnetic field or concentrate solar energy. The physicist asks the essential question, is this feasible according to the known laws of nature? their models and experiments either lend credibility to the idea or send the researchers back to the drawing board, ensuring the entire investigation remains grounded in scientific reality. The anthropologist completes the picture by living with and learning from modern indigenous communities who have maintained a continuous connection to their ancestral lands and practices. They record the songs and stories not as fairy tales, but as potential repositories of ancient environmental knowledge. A folk tale about a trickster spirit causing a landslide might actually encode a warning about the dangers of deforestation on an unstable slope. A specific rhythm played during a ceremony might be more than just music. It could be the remembered key to a vibrational practice that once encouraged rain. The anthropologist provides the cultural context, helping to decode the why and the how behind the physical evidence, revealing the holistic worldview that wove this technology into the very fabric of daily life and spirituality. The magic happens when these disparate threads are woven together. A LiDAR scan from an aircraft, a technology that uses lasers to see through dense jungle canopy, reveals the ghostly outline of a vast, ancient water management system surrounding a Mayan city, canals and reservoirs that no one knew were there. The climatologist then cross-references this discovery with regional pollen samples from the same era, showing a surprising abundance of crop pollen and a decrease in drought-resistant wild plants, indicating a period of reliable moisture. The archaeologist finds inscriptions at the site describing ceremonies dedicated to the wind and rain gods. The physicist models the flow of air through the city's layout and determines that the placement of the pyramids could indeed create a venturi effect, funneling and accelerating cool breezes through the main plaza. Suddenly, what looked like a city built for gods and kings begins to look like a meticulously engineered environment for human comfort and agricultural abundance. This is the power of interdisciplinary work. No single researcher could have seen this whole picture. It is only by bridging the gaps between science and history, between data and story, that we can finally hope to hear the faint echo of a forgotten technology and understand the true genius of those who came before us. Moving beyond the stone and sound of ancient engineering, we find another layer of this mystery embedded within the art and sacred objects these cultures left behind. The vivid murals, intricate pottery, and symbolic carvings that have survived the millennia are often dismissed as mere decoration or religious iconography. But what if they were something far more practical? Imagine a society that hadn't yet developed widespread literacy, or one that chose to encode its most vital knowledge in a universal visual language. Their art wouldn't just be for beauty, it would be a functional library, a durable record of techniques essential for survival. In this light, the dramatic image of a Mayan king holding a bizarre, serpent-shaped object isn't just a portrayal of royal power, it starts to look like an instructional diagram, a depiction of a tool used in a ceremony designed to call forth the rains upon which his entire kingdom depended. This idea of art as a technical manual becomes even more compelling when we examine specific, recurring symbols across different and seemingly disconnected cultures. Take the spiral, for instance. This motif appears everywhere, etched into the stones of Newgrange in Ireland, painted on Minoan pottery in Crete, and carved into temple walls in ancient India. While often interpreted as a symbol for the journey of life or cosmic energy, its prevalence in water management contexts suggests a more concrete meaning. A spiral perfectly represents a vortex, a whirlpool, the powerful motion of swirling water or wind. Its persistent use near aqueducts, reservoirs, and drainage systems implies it could have served as a symbolic marker for water flow, or even a schematic for a specific type of vortex-based technology used in filtration or aeration. Similarly, the universal zigzag pattern, so commonly associated with lightning and rivers, might be more than a simple abstraction. On a piece of Mesopotamian pottery, a zigzag flowing from a vessel could symbolize irrigation. Carved above the doorway of an Andean temple, it might denote a structure designed to attract or harness atmospheric electricity. These weren't just pretty patterns, they were a cross-cultural vocabulary for representing the forces of nature and humanity's interaction with them. Perhaps the most evocative example of this symbolic language is the Egyptian ankh. We know it universally as the symbol of life, but its frequent depiction in temple art tells a more dynamic story. You'll often see a pharaoh presenting the ankh to the nostrils of a god, or a deity holding the ankh while standing on a representation of water or wind. The ankh itself is sometimes shown with tiny lines radiating from its loop, or with waves cascading from its crossbar. This imagery powerfully suggests that the breath of life being offered or controlled was not purely spiritual, but quite literal. It was the air itself, the humidity in the wind, the life-giving moisture that prevented drought and sustained the Nile's fertility. The ankh, in this context, transforms from an abstract symbol into a potential glyph for a technology or a process that generated or stabilized these vital atmospheric conditions. A secret so important it was placed in the hands of the gods and the god-kings who served them. This fusion of the spiritual and the technical was likely the key to the long-term preservation of this knowledge. By embedding survival instructions within a sacred, ritual context, ancient societies ensured their continuity. The specific steps to activate a water collection system or the correct frequency to sound during a drought weren't written in a manual that could be burned or lost. They were choreographed into a dance, memorized as a prayer, painted on the wall of a temple, or woven into the pattern of a ceremonial garment. The ritual became the container for the data. A shaman's rattle wasn't just a noisemaker. Its specific sound and the way it was shaken might have been designed to replicate the frequency needed to vibrate a certain type of stone to attract moisture. The ceremony ensured that this precise action was performed correctly and passed down through generations, preserving the science within the shell of spirituality. The art that recorded these acts was therefore multidimensional, serving both to inspire awe and to instruct the initiated, ensuring that the practical wisdom of the storm vaults would endure long after the original engineers were gone. When we start to map the locations where these architectural and environmental anomalies are most concentrated, a fascinating pattern begins to emerge across the globe. It appears that the most compelling evidence for ancient climate engineering isn't scattered randomly, but is instead clustered in specific geographical hotspots, regions where the very volatility of the environment may have forced human ingenuity to its absolute limits. These were places where survival wasn't just a matter of enduring the seasons, but of actively wrestling with the elements to create pockets of stability and abundance. Let's journey to some of these key regions, starting with the sun-drenched cradle of Western civilization, the Mediterranean basin. Here, amidst the azure waters and rugged coastlines, advanced cultures like the Minoans on Crete and the maritime Phoenicians built their stunning cities. The Minoan palace of Knossos, for instance, wasn't just a political and ceremonial center. It was a marvel of environmental design. Archaeologists have uncovered sophisticated systems of ventilation shafts and light wells that channeled the cool, north-facing breezes through the vast complex, creating a natural air conditioning system that mitigated the intense Mediterranean heat. Furthermore, their advanced drainage and water management systems, which included terracotta pipes and carefully graded channels, weren't just for sanitation. They were likely designed to control runoff during sudden, torrential rainstorms, preventing erosion and flooding while also capturing precious water for the dry season. The Phoenicians, master sailors who understood wind patterns like no one else, are believed to have constructed their coastal cities with breakwaters and harbors that were expertly aligned to mitigate destructive storm surges, suggesting a deliberate effort to engineer a safer maritime environment. This intimate knowledge of wind and water wasn't just practical. It was essential for thriving in a region blessed with abundance but also prone to sudden, violent climatic shifts. Crossing the Atlantic, we find another set of powerful examples in the ancient Americas. In the high-altitude basin of what is now Mexico, the sprawling metropolis of Teotihuacan presents a masterpiece of urban planning with a potential climatic purpose. The city's central axis, the Street of the Dead, is precisely aligned not with true north but 15.5 degrees east of it. This specific orientation has long puzzled researchers, but some theories suggest it was designed to track the Pleiades star cluster, whose appearance in the sky marked the beginning of the rainy season, a critical piece of knowledge for agricultural planning. Even more impressive are the remains of what appears to be a massive, city-wide water control system. Channels and drains found beneath the Ciudadela, a vast sunken plaza, hint at a sophisticated network for managing water, perhaps to prevent flooding during summer storms or to create reflective pools that would cool the air through evaporation. Further south, in the harsh, high-altitude plains surrounding Lake Titicaca, the city of Tiwanaku stands as a testament to survival against the odds. Here, the engineering was focused on defeating frost. The Tiwanaku constructed vast, raised agricultural fields known as sucacolos. These were not simple garden plots, they were complex systems of elevated soil beds surrounded by canals. During the day, the water in these canals absorbed heat from the intense sun. At night, as the frigid alpine air descended, this stored heat was slowly released, creating a protective thermal blanket that warmed the soil and prevented frost from killing crops like potatoes and quinoa. This was climate control on a community scale, a technological solution that turned a marginal environment into a breadbasket. Venturing into Southeast Asia, the scale of hydrological ambition becomes truly staggering. The Angkor complex in Cambodia is world-famous for its temples, but its true genius lies in the invisible engineering beneath the jungle. Recent LiDAR technology has revealed that Angkor was the heart of an immense, low-density urban sprawl integrated with the most extensive water management network of the pre-industrial world. This system included massive reservoirs called barrays, canals, moats, and intricate embankments that stretched for hundreds of square miles. This wasn't just for show or for simple irrigation. Researchers now believe this vast network was a sophisticated tool for taming the monsoon. During the intense wet season, the canals and reservoirs would capture and store enormous quantities of rainwater, preventing catastrophic flooding in the urban center. Then, throughout the relentless dry season, this stored water would be gradually released to irrigate rice paddies, maintaining soil moisture and humidity levels across the region. By doing so, the Khmer engineers didn't just react to their climate. They effectively flattened the extreme peaks and valleys of the seasonal weather, creating a more stable and predictable environment that could support a population of nearly 1 million people at its height. Even in the remote and windswept British Isles, far from these sun-baked empires, we find intriguing clues. The great Neolithic monuments like Stonehenge and Newgrange are famous for their astronomical alignments with the solstices and equinoxes. While these are often interpreted for ceremonial or calendrical purposes, their potential role in climatic prediction cannot be overlooked. An accurate solar calendar was the most powerful tool an ancient society could possess. Knowing precisely when the seasons would turn allowed for the optimal timing of planting and harvest, a fundamental form of risk management in a cool, unpredictable climate where a late frost or an early winter could mean famine. The very act of marking these celestial events with such permanent, massive stones suggests that understanding and anticipating climatic cycles was absolutely central to their culture and survival. The placement of these sites in the landscape, often on high ground or near specific water sources, may also have been part of a broader strategy to observe weather patterns and interact with the atmospheric forces that shaped their lives. This global mapping reveals a profound and telling pattern. These hotspots of ancient innovation are not random. They are predominantly located in climatically volatile zones, arid deserts, monsoon-prone regions, high-altitude plateaus, and temperate zones with unpredictable weather. This is not a coincidence. It suggests that the drive to develop storm vault technologies was not born from idle curiosity, but from urgent necessity. The environmental challenges in these regions were so severe that passive adaptation was not enough. Survival demanded active, intelligent intervention. Whether this knowledge was developed independently in isolated pockets of innovation, or whether it was shared along ancient trade routes, is a question that continues to fuel debate. What is undeniable is that from the deserts of Persia to the jungles of Cambodia and the high plains of the Andes, humanity's ancestors were looking up at the same threatening skies and with remarkable ingenuity were learning how to answer back. To truly grasp how ancient societies might have engineered their environments, we must step into a world where the line between the temple and the laboratory simply didn't exist. For these cultures, a prayer for rain and a scientific attempt to induce it were one and the same act, two sides of a single coin. This fusion of faith and function wasn't a sign of primitive thinking. It was a sophisticated system for preserving and applying hard-won knowledge about the natural world. The rituals we often dismiss as superstitious, the rhythmic dances, the precise chants, the offerings left at an altar, were likely the delivery mechanism for a deep, empirical understanding of ecology, wrapped in a spiritual package to ensure it was remembered, respected, and correctly performed for generations. Consider the incredible precision of timing in these ancient ceremonies. A rain dance wasn't performed on a random Tuesday out of desperation. It was executed at a very specific time of year, often marked by a distinct celestial event. The Dogon people of Mali, for instance, based their intricate Sigwi ceremony, which is deeply connected to renewal and fertility, on the complex 60-year orbit of the star Sirius. This kind of astronomical accuracy suggests these rituals were scheduled to coincide with verifiable climatic shifts, the arrival of seasonal winds, the change in atmospheric pressure before monsoon rains, or the period when certain plants released pollen that could act as natural cloud seeding agents. The ceremony was the public activation of a system whose operational principles were understood through meticulous, long-term observation. The spiritual leader orchestrating the event was less a mere priest and more a head scientist, consulting an celestial calendar and environmental data to determine the optimal moment to implement a community-wide intervention. This practical application becomes even clearer when we examine the tools of these rituals. Take the humble incense burner found in cultures from ancient Greece to Mesoamerica. While its smoke was a symbolic offering to the gods, the specific herbs and resins burned within it may have had a direct atmospheric purpose. Scientists now know that the smoke particles from certain burning materials can act as cloud condensation nuclei, tiny surfaces around which water vapor can coalesce, forming droplets heavy enough to fall as rain. A ritual that involved the community in burning vast quantities of a specific plant at a precise time could have been, in effect, a large-scale cloud seeding operation, its chemical mechanics hidden within a sacred act. Similarly, the relentless, deep-frequency beating of a large drum during a ceremony, might have been designed to do more than just summon spiritual energy. As modern acoustic research is exploring, specific low-frequency sound waves can vibrate water droplets in the air, encouraging them to merge and grow. The shared rhythm united the community in a common purpose, while the physics of the sound waves worked on the atmosphere itself. This beautiful integration of belief and technology created an incredibly resilient social framework. Because these environmental practices were embedded within a religious and cultural context, everyone in the community understood their role and participated in their upkeep. Maintaining an irrigation channel wasn't a chore, it was a duty to the water deity that sustained life. The knowledge of which way to orient a house to catch the breeze wasn't just good construction, it was a way of honoring the wind god. This system ensured the vital information for survival was not held by a few elite technicians, but was woven into the very identity of the people, preserved through song, story, and repeated ceremony. It made every individual a steward of their environment, personally invested in the balance of the natural systems that allowed their society to flourish. This holistic model, which viewed science, spirituality, and community as a single, integrated whole, offers a profound contrast to our modern, often fragmented approach to environmental problems, reminding us that the most sustainable solutions are those that are culturally cherished and collectively owned. This very question lies at the heart of a profound and unsettling paradox. If these ancient societies possessed such remarkable mastery over their environments, what could possibly have brought them to their knees? The evidence points us toward a complex web of failure, where technological sophistication itself may have sown the seeds of its own destruction. It's a story not of a single cataclysm, but of a slow unraveling, where the very systems designed to ensure survival became vulnerabilities when the world around them shifted in unexpected ways. Consider the magnificent Maya, whose cities were marvels of hydroengineering, complete with massive reservoirs, intricate canal systems, and paved catchment areas designed to capture every precious drop of rainwater during the seasonal downpours. Their entire civilization in the southern lowlands was built upon the promise of this carefully hoarded water, a buffer against the dry season. For centuries, it worked brilliantly, supporting a population density that rivals some modern cities. But then the rains began to fail. Paleoclimatologists studying sediment cores from nearby lakes have identified a series of intense, multi-decadal droughts that struck between the years 800 and 950 CE. The Mayas' vast reservoirs, once their salvation, became their tombs. As the water levels dropped, these stagnant pools would have become breeding grounds for disease and algae, while the concentration of human waste would have rendered the remaining water undrinkable. Their entire society was exquisitely tuned to a specific climate pattern, and when that pattern changed beyond the capacity of their technology to adapt, the collapse was swift and brutal. Their advanced water management, a testament to their genius, ultimately created a rigid system that could not bend without breaking. A similar story of environmental hubris may have played out far earlier in the heart of Mesopotamia with the collapse of the Akkadian Empire around 2200 BCE. This was the world's first true empire, a superpower that unified the city-states of Sumer and Akkad under one ruler. Their agricultural wealth was built on a sprawling network of irrigation canals that fed water from the Tigris and Euphrates rivers to their fields, allowing them to turn the arid plains into a breadbasket. For a time, it was a spectacular success, but irrigation, if not managed with extreme care, carries a hidden, slow-acting poison, salinity. As water evaporates from the fields, it leaves behind dissolved salts that gradually accumulate in the soil. Year after year, harvest after harvest, the salt levels built up, slowly poisoning the land. Cuneiform tablets from the period tell a desperate story, recording a catastrophic shift in what they could grow. The preferred salt-sensitive wheat crop began to fail, forcing a switch to more salt-tolerant barley. Eventually, even the barley yields plummeted. At the same time, ice core records from distant glaciers and sediment analyses from the Gulf of Oman point to a severe, centuries-long drought that gripped the region. The Akkadians' magnificent irrigation network, facing a drastically reduced river flow, would have accelerated the salinization process, concentrating the salts even further. Their sophisticated technology, designed to defy their arid environment, ultimately amplified the effects of a changing climate, leading to famine, social unrest, and the disintegration of history's first great empire. It is a stark lesson in unintended consequences, where a solution for one problem can quietly create a far greater one down the line. These historical collapses force us to confront the inherent vulnerabilities of any climate control system, no matter how advanced. The first great vulnerability is a reliance on finite resources. The Maya depended on predictable seasonal rainfall to fill their reservoirs. The Akkadians depended on the consistent flow of two great rivers. When those foundational resources diminished or changed character, the entire technological edifice built upon them became unstable. The second vulnerability is a lack of adaptability, or what modern engineers call resilience. These systems were often optimized for peak efficiency under specific conditions, but that very optimization made them brittle. A smaller, more decentralized system of water collection, one that incorporated a diversity of sources like groundwater, fog capture, and smaller, scattered cisterns might have been less efficient in good times but far more likely to survive a prolonged drought. The grand, centralized scale of their projects created a single point of failure for entire civilizations. This is perhaps the most crucial lesson for our own time, as we contemplate global-scale geoengineering projects. Are we designing systems that are robust and flexible enough to handle the unpredictable shocks of a changing planet? Or are we building new, even larger versions of the same brittle monuments? The fall of these systems also plunges us into a deeply troubling mystery. What happened to the knowledge itself? How does an entire civilization simply forget how to keep itself alive? One possibility is that the collapse was so total and so traumatic that it resulted in a civilizational reset. Imagine the few survivors of a Maya city, scattered by famine and warfare, struggling to subsist in a broken landscape. The intricate knowledge of hydrology, astronomy, and masonry held by the priestly and engineering classes would have died with them, as the daily struggle for survival took precedence over preserving abstract knowledge for a future that seemed to have vanished. The surviving population would have had to revert to a much simpler way of life, and over just a few generations, the grand purpose of the crumbling reservoirs and palaces would have faded into legend, then into myth. Another, more chilling possibility is that the knowledge was deliberately suppressed or abandoned. If a ruling class's authority was based on its perceived ability to control the climate, and then the rain still failed, it could have led to a violent rejection of that entire belief system and the technological practices embedded within it. The temples might have been torn down, the priests overthrown, and the old ways condemned as a failure or even an affront to new gods. This erasure of knowledge wouldn't have been malicious. It would have been a desperate act of a society trying to find a new path after the old one led them to ruin, a tragic case of throwing the baby out with the bathwater. The silence of the ruins, then, is not just a result of decay. It is the echo of a profound and catastrophic forgetting, a warning that our own hard-won knowledge is far more fragile than we dare to believe. In a world increasingly desperate for sustainable solutions, a quiet revolution is taking place in the fields of architecture, agriculture, and even atmospheric science. and its inspiration is coming from a most unexpected place, the distant past. Faced with the limitations and environmental costs of high-energy technologies, modern innovators are turning back the clock, rediscovering ancient principles of working with nature rather than fighting against it. This isn't about nostalgia, it's a pragmatic, evidence-based return to strategies that have been proven over centuries, and in some cases, millennia. The movement is clear. The wisdom of our ancestors is becoming the cutting edge of our green future. One of the most successful adoptions of this ancient wisdom is in the realm of green architecture. The soaring energy demands and carbon footprint of conventional air conditioning have pushed architects to seek passive, natural solutions. Their search led them directly to a centuries-old technology from the Middle East, the Persian wind catcher or badger. These magnificent towers, designed to capture even the faintest breeze and funnel it down into the heart of a building, are masterpieces of passive cooling. Today, this principle is being integrated into modern buildings worldwide. In the desert climate of Arizona, new commercial buildings feature updated versions of these wind catchers, often coupled with underground earth tubes that pre-cool the air using the stable temperature of the soil. The result is a dramatic reduction, sometimes even the complete elimination, of the need for mechanical air conditioning, slashing energy consumption and utility costs while providing a natural, draft-free comfort that modern systems struggle to match. This return to roots is even more vital in our approach to feeding the world. Industrial agriculture, with its reliance on monocropping, heavy tilling, and chemical fertilizers, has led to catastrophic topsoil erosion and depleted ecosystems. In response, forward-thinking farmers and agroecologists are looking to the past for a more resilient model. They are reviving the ancient Andean practice of terrace farming, which transforms steep, erosion-prone slopes into a series of level, fertile steps. These terraces do more than just prevent soil loss. They create microclimates, conserve water, and allow for a diversity of crops to be grown in a small area. This is being combined with polyculture, a method practiced by indigenous communities for thousands of years, where multiple complementary plant species are grown together. This creates a symbiotic relationship that naturally enriches the soil, controls pests, and increases overall yield and nutritional density, offering a powerful, sustainable alternative to the fragile monoculture system. Perhaps the most futuristic and surprising resurrection of ancient tech involves the power of sound. For years, stories of tribal rain dances and legends of instruments that could calm storms were dismissed as folklore. Now, a small but dedicated group of physicists and engineers are taking these tales seriously, exploring the potential of acoustic technology for weather modification. The theory is that specific, low-frequency sound waves can influence the behavior of water droplets in the atmosphere. In practical terms, this has led to experiments using powerful, ground-based speakers to emit targeted frequencies. Some projects aim to disperse fog over airports and highways, improving safety without the environmental impact of chemical agents. Others are more ambitious, testing whether these sonic vibrations can encourage the coalescence of water vapor in clouds, potentially triggering rainfall in drought-stricken regions. While still in its experimental stages, this research validates a profound ancient intuition. That vibration is a fundamental force that can interact with the very building blocks of our atmosphere. This global revival is about more than just borrowing old ideas. It represents a crucial shift in philosophy. It moves us away from a paradigm of domination and extraction toward one of collaboration and harmony. By studying these ancient systems from the storm vaults to the qanats, we are tapping into a vast reservoir of knowledge that emphasizes adaptation, resilience, and a deep understanding of local ecosystems. This movement also fosters a new and essential form of collaboration. Scientists and engineers are increasingly partnering directly with indigenous communities, not to extract their knowledge but to learn from them as equal partners. This ensures that these traditions are not co-opted but are respected, ethically integrated, and that the communities who preserved this wisdom for generations are recognized and benefit from its application in the modern world. In this beautiful convergence of past and present, we are not just discovering forgotten technologies, we are rebuilding a lost relationship with our planet, weaving together millennia of human ingenuity to create a future that is not only greener but also wiser and more deeply connected. So where do we go from here? The evidence we've gathered so far is compelling, but it's merely the first chapter in a much larger story. The path forward is paved with tantalizing questions that demand a new kind of exploration, one that bridges the gap between the ancient and the ultra-modern. One of the most profound unknowns is the true scale of this technology. Was environmental engineering a rare, localized practice, or was it a ubiquitous feature of advanced ancient societies, as common as monumental architecture or written language? We have compelling clues from places like the Indus Valley, Mesoamerica, and the Mediterranean. But what about the vast, unexplored regions of Africa, Central Asia, or the depths of the Amazon? The next great discovery might not be a single lost city, but the realization that an entire network of climate-managed sites once spanned the globe, suggesting a level of interconnected ecological thinking we never imagined. Unraveling this mystery will require a radical shift in how we conduct research, moving beyond the isolated silos of archaeology or history and into a truly collaborative, interdisciplinary future. Imagine a global project where artificial intelligence is trained to scan and cross-reference thousands of ancient texts from different cultures, not just for historical events, but for shared technical terminology related to weather, vibration, and water flow. An AI could identify patterns and correlations that a human scholar might never spot, perhaps finding the same obscure word for a specific type of condensate-collecting stone in both a Mayan codex and a Sanskrit manuscript, hinting at a previously unknown exchange of ideas across oceans. This digital archaeology would be paired with physical exploration on an unprecedented scale. Large-scale, focused excavations at sites already identified as potential storm vaults, like specific areas around the Giza plateau or beneath the Nazca lines, could finally reveal the subterranean chambers, resonant tunnels, or mineral deposits that formed the heart of these systems. We wouldn't just be digging for artifacts, we'd be digging for functionality, searching for the literal machinery of ancient climate control. Technology will be our greatest ally in this search, providing us with senses beyond our own. Satellite imaging and aerial LiDAR have already revolutionized our understanding of ancient landscapes, but the next generation of sensors will go even further. Hyperspectral imaging from space can detect minute changes in soil composition and moisture content, potentially revealing the ghostly outlines of vast, buried water channels or the chemical residue of ancient, engineered soils like terra preta, even beneath dense forest canopies or modern cities. On the ground, DNA analysis of soil samples offers another revolutionary tool. By sequencing the ancient DNA preserved in the earth at these sites, scientists can reconstruct the precise microbiome of the past. They could identify the genetic signature of plants that were specifically cultivated to modify local humidity or stabilize soil, or even find microbes that thrived in a uniquely managed environment, providing biological proof of human-led climate modification. This would move the evidence from the architectural and geological into the realm of the biological, creating an irrefutable multi-layered argument. Perhaps the most crucial and most overlooked resource in this entire endeavor is the living knowledge held by indigenous communities. For too long, Western science has dismissed their oral histories and traditional practices as mythology. The future of this research demands a new relationship built on respect and collaboration. Elders and knowledge keepers from cultures with deep ties to their land are not simply subjects to be studied. They are essential partners and colleagues. Their understanding of local weather patterns, plant properties, and ancestral stories could provide the key to interpreting archaeological finds correctly. A specific ritual or song might hold the clue to the acoustic frequency needed to activate a resonant chamber, or a traditional farming technique might explain the purpose of an oddly shaped terrace. This partnership ensures that the narrative we build about the past is not just accurate, but also respectful and inclusive, honoring the continuous line of wisdom that connects the ancient engineers to their living descendants. Finally, this quest cannot be confined to academia. The scale of the mystery is too vast, and the potential implications for our own world are too significant. The future of discovery lies in democratizing the search through widespread citizen science initiatives. Imagine a global network of enthusiasts using affordable satellite data to scan their own regions for previously unnoticed geometric patterns or hydrological anomalies. Or consider an app that allows people to upload images and sounds from ancient sites, contributing to a massive database that researchers can use to analyze acoustic properties or erosion patterns. By engaging the curiosity of millions, we can crowdsource the planet, turning every interested person into a potential discoverer. This collective effort not only accelerates research, but also fosters a deeper, more personal connection to our shared human heritage and the urgent environmental challenges we now face, ensuring that the secrets of the storm vaults are unlocked not just for knowledge's sake, but for the future of our planet. Our journey through the enigma of the storm vaults has taken us across continents and through millennia, from the wind-swept plains of Nazca to the silent, staring majesty of the Sphinx, from the resonant chambers of ancient temples to the living wisdom of indigenous elders. What emerges is not a simple answer, but a profoundly new way of seeing our ancestors and, by extension, ourselves. We began with a question that seemed to border on fantasy. Could ancient civilizations have actively engineered their climates? The evidence we've explored, the architectural genius, the acoustically perfect chambers, the mythological clues hiding in plain sight, and the unexplained geological anomalies paints a picture that is far more compelling than mere coincidence. It suggests a world where humanity's relationship with nature was not one of passive submission or brute force domination, but of active, intelligent partnership. This was a holistic science, one that wove together precise observation of the stars, an intuitive grasp of physics, and a deep spiritual reverence for the natural world into a seamless tapestry of survival and innovation. This re-evaluation of the past is not just an academic exercise. It holds an urgent and powerful mirror to our present moment. As we grapple with the escalating consequences of modern climate change, our ancestors' approach offers a paradigm shift. They demonstrate that sustainability is not about having less, but about understanding more. Their technologies were elegant, energy efficient, and built from local materials, designed to work within the Earth's existing systems rather than overwhelming them. The Persian windcatcher required no electricity, the Andean terrace farm needed no chemical fertilizers, and the acoustic rituals demanded nothing but knowledge and community participation. Their legacy challenges the very core of our modern industrial mindset, urging us to ask, can we pivot from a philosophy of extraction and control to one of integration and harmony? Can we learn to build and grow not just for maximum yield, but for maximum resilience and balance? Yet their story is also a cautionary tale of humility. The collapses of the Maya and the Akkadians stand as stark reminders that even the most sophisticated systems are vulnerable to hubris, rigid thinking, and unforeseen environmental shifts. They warn us that any technology, no matter how ingenious, is only as resilient as the wisdom of those who wield it. This is the most crucial lesson for our own era of geoengineering debates. As we consider deploying massive technological fixes to cool the planet, the ghost of Atlantis whispers a warning. We must proceed with caution, prioritizing adaptable, reversible, and ethical solutions that are guided by a profound respect for the complex, interconnected system we are attempting to influence. Ultimately, the greatest legacy of the ancient climate engineers may not be the stones they left behind, but the mindset they embodied. They saw themselves as custodians of a delicate balance, active participants in a living world. Their storm vaults were not just physical structures, they were the manifestation of a cultural ethos that embedded environmental stewardship into the very heart of daily life, spirituality, and community. This exploration invites us to look at every ancient ruin, every weathered symbol, and every old story with fresh, curious eyes. The past is not a closed book but an open conversation, filled with forgotten wisdom that is suddenly, desperately relevant. So what do you think? Did the ancients hold secrets we are only now rediscovering? Share your most intriguing thoughts and questions in the comments below. Let's keep this conversation going. If you enjoyed this deep dive into history's mysteries, please show your support by liking this video and subscribing to the channel for more journeys into the unknown. Thank you for watching, and never stop questioning the world around you.